Simplifying fractions. A fraction is formed by dividing a whole into a number of parts. An example of a fraction is 2 over 3, or 2/3. The bottom number is the denominator. The top number is the numerator. And the line that separates them is the division symbol, or the bar for the fraction, and it means division. Working with the property of 1, fractions, property of 1. If we have n is any integer other than 0, then n over n is going to equal 1. So n divides into n one time, or n times 1 is n. So in this case, you see 2 over 2 equals 1. So whenever you have the same thing over the same thing, it's going to equal 1. The other property of 1 with fractions is if n is any integer, then you can have n over 1 will equal n, or 3 over 1 equals 3, or vice versa. You could have a whole number and you can make it a fraction by putting it over 1. When we're talking about fractions and simplifying, what you're going to be doing is using common factors. You're going to simplify a fraction by dividing the numerator and the denominator by common factors until there's no longer common factors. So when I look at a fraction and I see two of the numbers are even, I usually start off with dividing out 2, because every even number is divisible by 2. So I start by dividing by 2 both the numerator and the denominator, and I will continue until they no longer have common factors. So I see that after I divide the numerator and denominator by 2, I get 16 over 20, and I know that they still have a factor of 2 because they're both even. So I would divide again by 2 and simplify, and I would get 8 over 10. So I see they're still not in simplest form, so I'm going to continue. I'm going to divide 2 out until they no longer have common factors. So my reduced fraction here will be 4 over 5. So for 32 over 40, to simplify, I would end up with 4 over 5. Now again, if you know the highest common factor or the greatest common factor for both the numbers, you can simply immediately divide that out and simplify the fraction. So make sure that when you have a final answer that it's always in simplest form, so you always are going to have to think, can I reduce out a common factor? Pause and try. So again, if you didn't know right off the bat the greatest common factor for both these numbers, you could start off with 2 because they're both even. I divide 2 out and I know that there's another 2 that can come out. And again, I continue until I no longer have common factors. So the simplified fraction for 16 over 24 would be 2 over 3. And of course, if you knew right off the bat that 8 is a common factor, you can divide that out immediately and get the same result. Pause and try. So in this case, the only common factor that 21 and 28 have is 7, so you divide it out and you end up with 3 over 4. Pause and try. Now I wanted to include this one. Whenever you have the same amount of zeros on top as on the bottom, you can cancel them off before you start reducing. So you're really reducing a 10 out. And then you can reduce the smaller fraction. So here I have 25 over 55, and a common factor would be 5. I divide it out of each term, and I'm left with 5 over 11. When we're talking about adding and subtracting fractions, to add or subtract fractions, we need to have like fractions. And when they're like fractions, you add the numerators and keep the denominator the same. So in this example, I have like fractions because my denominators are both 8. These are like fractions, and because they're like, I leave the denominator the same and I add the numerators. So in this case, when I add 4 over 8 plus 5 over 8, I get 9 over 8. And again, it has to have a common denominator in order for us to add or subtract fractions. Now we can leave this as an improper fraction because it's okay to have in algebra improper fractions. So you can just leave a higher number on top if you end up with the higher number. That's what an improper fraction is. Okay, so now we have like fractions. You always want to check that out. I know they're like because the denominators are the same. So I'm going to add the numerators here and I get 8 over 16. And remember, you always have to simplify your fraction or the answer is incorrect. So I see that I can reduce this fraction by 8, so I end up having 1 over 2. So always double check to see if it can be reduced. In this example, you see I have variables in the denominator. As long as the denominators are the same, and in this case they are, 10x, 10x, they're both the same, then all I have to do here is add the numerators and keep the denominator the same. Once you get to this point, if you can reduce, you need to reduce. And I see that the 10 over the 10 would reduce, but that x is not going away. Keep in mind though, the x is in the denominator, so you need to keep the x in the denominator and put the 1 above. So it's very important that you reduce correctly and that the variable stays in the denominator. Pause and try. So you see in this case, I have same sign, which means I'm adding and keeping the sign. I have a common denominator. So I end up adding the negative 5 minus 1, getting a negative 6. Keep the signs. And then I know I can reduce here because they're both even. So I reduce the fraction and my final answer would be a negative 3 over 4x. Pause and try. Okay, so we have like denominators. I can perform the operation. In this case, I have different signs. I need to subtract and keep the sign of the higher number. So I end up with a negative 4 over 12, and I see it can reduce. So my final answer would be a negative 1 over 3. Now, when we do not have like fractions or the same denominator, we're going to need to create that. So when we do not have the same denominator, we're going to need to find the least common multiple. Before I start doing work to find the least common multiple, the first thing I'm checking with the denominators of the fractions is, does my smallest denominator divide in evenly into the larger? If my smallest denominator divides in evenly into the larger, then the largest denominator will be my least common multiple. So always check for that scenario. The next thing I check for is if one or both of the denominators are prime numbers, then the least common multiple will be the product of those two numbers. So when you are looking at the denominator, if the smallest does not divide in evenly into the largest, the next thing you want to check is one or both a prime number? If one or both a prime number, then you're going to need to find the least common multiple by multiplying the two numbers together. If it's neither one of these cases, you're going to need to use the ladder method to find your least common multiple. After you find the least common multiple, do an example here. So the first thing I'm checking is, does the smallest denominator divide in evenly into the larger? And I see here 3 divides into 15. Therefore, 15 will be my least common multiple or my common denominator. So I need to convert the fractions to have a denominator of 15. The first fraction already has that denominator, so I'm just going to bring it down. So I'm going to bring down the 2/15. The second fraction I need to convert to have a denominator of 15. So I have to multiply 3 by 5 to get 15, and whatever you multiply the denominator by, you need to multiply the numerator by. So I multiply 1 times 5 and I get 5. So now I have the converted fraction, I have like denominators, and all I have to do here now is add the numerators and keep the denominator. This next example, again, you want to check, does the smallest number divide evenly into the larger? And in this case, it does not. 3 doesn't divide into 7. But I do note that 3 and 7 are both prime numbers. So the only way to get the least common multiple is to multiply the two denominators together. So I multiply 7 to 3 and I get 21. So my common denominator is going to be that least common multiple of 21. In this case, I'm going to need to convert both fractions to have that denominator of 21. So the first fraction, I need to multiply 7 by 3 to get 21. So whatever I multiply the denominator by, I need to multiply the numerator by. So I end up with 6 over 21. The second fraction, I need to multiply 3 by 7. And whatever I multiply the denominator by, I need to multiply the numerator by, so I end up having 7 over 21. Now I have like fractions, so I can add the numerators, and I am left with 13 over 21. Pause and try. Okay, so you see here, 6 divides into 12. My least common multiple would be 12. So the first fraction I leave alone. The second fraction, I multiply the top and the bottom by 2, and I convert the fraction. Now I have a common denominator. I add the numerators, and I get 7 over 12. Pause and try. So here you see that 6 doesn't divide into 11, but 11's a prime number. So my least common multiple will be 66. The first fraction I need to multiply by 11. So I end up with 55 over 66. The second fraction I multiply by 6. So I end up with 42 over 66. And now I can add the numerators. And I have an improper fraction, and that's okay. That would be my answer. Pause and try. Again, 4 divides into 8. So 8 would be my least common multiple. Be careful of signs here. I have different signs. The first fraction I do not need to convert. The second fraction I'm multiplying the top and the bottom by 2. So I end up with negative 7/8 plus 6/8. Different signs mean I'm subtracting and keeping the sign of the higher number. So I end up with a negative 1 over 8. Pause and try. Again, the way to get the common denominator is to multiply 3 and 4, and I get 12. I need to convert the first fraction by multiplying the top and the bottom by 4. I need to convert the second fraction by multiplying the top and the bottom by 3. And now I have my converted fractions. Keep in mind, I have same sign here, so I'm going to need to add and keep the sign. And I'm left with the negative 13 over 12.